I am not fond of Monsanto. But what is inspiring is the way they use IP. So Monsanto started off by making sugar. Do you know that there was a very dangerous chemical that was being used in the Vietnam War called Agent Orange?
Yeah.
Monsanto was the main supplier, the only supplier.
Sarin.
Sorry?
Sarin, it is.
Sarin, yes. Also, sarin is the nerve gas that was
related to.
Yes, okay. So, dioxin is the name of the company. Okay? Monsanto produced dioxin. It was a company that specialized in technologies that were destructive to human beings and other animals and plants. If you use dioxin, the reason they used dioxin in such large quantities in Vietnam was because they found that the forests were so thick that you could not enter. So the American government said, just destroy the forests. And now they're doing that in Afghanistan. So they destroyed the forest, but along with it they also killed the soil, the waters, the underground waters, microbes, everything got destroyed, people too of course. So that is the kind of company that Monsanto is. But somewhere along the way, it became a seed company. How did it become a seed company? In 1970, it developed a chemical called glyphosate. Glyphosate is a herbicide. It kills plants. It kills all plants with a soft bark. If the bark is hard, it is less easy to penetrate. If the root is very long, then it is difficult to penetrate. But largely, it will kill all plants in the nature of weeds. Why do you think this was essential?
For the weed management.
Okay, for weed management. Now, does that mean only weeds die? Any plant would die. So that means you have to be really careful. You know, there is a flower bed and there is weed. You have to be very careful to administer glyphosate. But from 1973, it became very, very popular as a weed killer. And it spread all over the world. China, Southern Europe, Northern Europe, everywhere people were using glyphosate. The patent expired in 2000. Of course, you will understand the technology better, but glyphosate inhibits the enzyme which synthesizes aromatic compounds, aromatic amino acids in the plant, okay? And it is only active on growing plants. So a fully mature wheat plant will not be effective, okay? Now, what happened after that? What is the next step? After developing glyphosate, which is a successful technology, what would a normal theory be?
Resistant to that.
Too resistant. That is what Robert Shapiro, who was the IP lawyer of Monsanto, said. He said, now the time is to develop something resistant to it. Okay, which was completely contrary to the going IP idea that you have a degree of effectiveness, make it a plus degree of effectiveness. But he said, no, you have a degree of effectiveness, that is fine. Now develop a plant that resists that. What do you think is the value of that? Why should you have resistant plants?
Because it is not selective. Now they want...
What is the objective of having resistant plants?
They will be the owner of such variety.
That is so. So what? No, but what is the farmers
to safeguard the good plant. Beneficial plant.
The idea was, as Madam pointed out, they had huge farms. Okay. Now, glyphosate has to be administered by a person going into the plants. But once you have glyphosate resistant plants, you can overfly and spray them. That will save you a lot of labor. So that's how you got Roundup ready, which was plants that were ready for Roundup. Now they went with both. In Argentina, for instance, India also. In Argentina, for instance, both the seed and that is the Roundup ready seed and glyphosate are sold together with royalty. If you buy Roundup ready, you have to buy Roundup. If you buy Roundup, you have to buy Roundup ready. So for the price of one, you sell two products. Do we do that in India? Yes. We buy seeds which will only grow with fertilizer, and we are sold fertilizers, isn't it? If you go as a farmer to get a subsidy, a farm subsidy to grow product, 40% of the value of your money will be given in fertilizer. 60% in terms of seeds. If you buy this fertilizer, you have to use only these seeds. If you buy these seeds, you have to use this fertilizer. Otherwise, it doesn't work. So this is the way farming companies work, whether in India or abroad. Now, what Monsanto does next is even more interesting. Glyphosate patent expired in 2000. Chinese glyphosate has flooded the market. Still they are sending Roundup ready seeds because that patent is still subsisting. What they do is they integrate seed genetics to protect yield tolerance and also breeding technologies like BT. Okay, now you don't need glyphosate at all because the plant will not get attacked. If you have BT in a BT gene in a product like soybean or wheat or cotton, then it is not going to get attacked at all. So it doesn't need glyphosate at all. But if you see, interestingly, this is where your answer will come, sir. It's called Roundup Ready Genuity. So Roundup has a brand in the people's mind. Roundup is still important at that generation because Roundup seeds are good. Roundup seeds are high yielding varieties. In the next one, SmartAx gone, if you see, Roundup is gone. So now you don't want the bad name. Okay? And genuity becomes the new trademark of Monsanto. So the reason I am showing you this is, it is not necessary that a research organization should be so conservative in its mindset that it should think only in one direction. Here you have an industry player, an agricultural industry player, who uses IP in an effective way. One, to ensure markets globally. Second, to transform itself from a killing company to a seed company, life-giving company. That is the way now they talk of Monsanto. And of course, they have bought up all the seed companies of the world. Monsanto is the largest seed company in the world. So you have, now again to go back to your answer, Monsoy, Decal, Cargill, Asgrow, Stein, Agracetus were all trademarks. They were all trademarks because Monsoy was coming from Monsoy. Now Monsoy is a brand name of Monsanto. You see what I am saying? So no longer does it tell you that this company or Decal or Cargill or the seed company of Cargill does not come from Cargill. Do you know the brand Sweekar? Sweekar was an oil which was coming out from Marico Industries. It has now been bought by Cargill. So it is no longer a trademark of Marico. It is a brand name of Cargill. So what we are looking at is how in agriculture and industry there is a movement towards IP based value generation. We were discussing that in other countries agriculture is treated as an industry. Let us really look at what is happening in these countries. How many of us know about American cyanamide? Not many. American cyanamide was started in 1907 by a person called Washburn. Washburn built dams for hydroelectricity. Okay? He built dams for hydroelectricity. After building 3 dams, he said, I have surplus electricity, what shall I do with it? He discovered or he found that there was somebody with a patent for extracting nitrogen from air using electricity, using an electric arc. So if you pump a very high degree of electricity in air, then it breaks up into its compositional ions. So air is 21% oxygen, some 0.9% something carbon dioxide and 72% nitrogen. So when you pass electricity through it, you get nitrogen. Okay? And nitrogen is a good fertilizer. So he said, I will develop nitrogen from air using electricity that I develop in my dam. So he built a dam on the Niagara in Canada, Ontario, and developed a process by which he could make nitrogen and sell it to farmers. This is how the fertilizer industry developed around the agriculture industry. Subsequently, he bought a company called Amorphos, which was developing phosphates. So now you have nitrogen, and by then he had developed calcium, and now you have phosphate. So all the minerals that you require for agriculture, and agriculture and farmers around America and in Europe immediately became fertilizer dependent. And primary to remember is fertilizer is a electricity intensive process at this point. Of course, later it became chemical intensive. Thereafter, he moved into vulcanization of rubber, he moved into vaccines. How did he move into vaccines? As he was developing, not he, but his scientists were working on vulcanization of rubber, they discovered polio vaccine. Because it is a byproduct in vulcanization of rubber. Why am I pointing this out to you? Let's go to the next one. BASF. BASF and International Mineral Corporation are mining companies in the US. As they mine, they come across many micronutrients like magnesium, lithium, sodium, nitrates of potassium, so many different things which we need for animals, plants and human beings. Iodine. Okay, so what have they done? They have come together with the UN to provide micronutrients to people and animals in the third world. And how do they do it? Just look at that patent which has been filed. It is a pellet which can comprise of all these micronutrients, which is inserted behind the ear of animals and will keep supplying small doses of micronutrients to that animal. The third one, BCIL, is an Indian company sponsored by the Indian government. There are patents by MSSRF for transgenic varieties of rice. What are these transgenic varieties of rice? They are rice with certain genes which will help them to overcome salinity in water or water logging. Okay, and they are also doing some work by which they can overcome certain mineral concentrations in kalpaka. So patents have been filed for this. Now these patents, these transgenic rice varieties are dependent on other patents filed by Monsanto, Cargill and so on. So neither BCIL nor MSSRF can independently market these varieties. They will have to either pay royalty to those companies or sell these auxiliary inventions to the companies which hold the mother patents or hold the larger family of patents. Why do you think I have these examples where industry is providing answers in veterinary and agricultural science? The reason I brought them out is, you cannot remain in the pond and understand the pond. It needs this kind of a cross-disciplinary approach. A mining company, how does it enter veterinary science? Or even mammalian science, because micronutrient project is with human beings. So how does a mining company understand health science? The reason it does is because it has an IP specific approach. It says, I have a product, I must find a market. Or I have these byproducts, these things are coming out which I don't know what to do with. Let me find something to do with them. That kind of focused commercial approach is very essential. This is a company that I talk about. This is a Hyderabad based company, not very profitable at the moment, but hopefully it will grow. The reason I brought it out is, it has an approach which is similar to what we are talking about. So, it is a biodiesel firm. It develops biodiesel. But the exciting thing about Nandan is, it starts from making genetically modified cultivars of Jatropha to second generation development of diesel. So it overtakes the entire process. Of course, if you see how they have connected with different people. You see, in the first part, they have connected with the WIPO. The second part, they have connected with the local panchayat. And they moved on franchisee, farmer, financial service producers, joint venture, government research and technology institutes. And if you see the last part, it is to harness the byproducts and derivatives in addition to biodiesel. So in this world, in this IP specific technology world, you cannot have a useless byproduct. Unless you find a use for it, it sometimes makes the entire process too expensive. Why does it happen with biodiesel? Biodiesel is you need to get huge amounts of feedstock to produce a small quantity of biodiesel. Biodiesel is density is very low compared to fossil fuels. So you have to add certain things to make it thicker and thicker. And the feedstocks, you have to fill rooms and rooms of it because plants are large. The body of plants is large. And unlike fossil fuels, which can remain in the earth and you just suck out whatever you want, here you have to actually transport that to the final plant and then again get rid of it. So that is where comes the whole process. Logistics will become too expensive. That was actually this was actually the ground for that game that we played. So logistics will become too expensive to move everything and then to throw it back in the garbage dump. So what Nandan has done is it starts looking at the entire process. How can you reduce the feedstock? How can you reduce the feedstock? By increasing the quantity of hydrocarbon or possibility of hydrocarbon in the plant. And then it does hybridization, mutation breeding, alteration of sex ratio and mass multiplication by tissue culture. So by doing all this, it improves the feedstock. The company improves the feedstock in Chhattisgarh. That is where their farms are. And then the crop management. So this is for instance, this would be the source of good quality crop, and that will be good breeding practices. So the farmers are integrated, the panchayats are integrated, small farmers come together, eventually it will become a large farm. So you have a crop integrated management system. You also have a fodder management system. So some of it can be used as feed and fodder for animals. Propagation, canopy pruning and architecture. So these are whether you should have terrace fields, whether you should have canopy, whether you should have pruning. So they have studied the actual structure of how the crop is growing in various areas. If you look at their research agenda, I mean, this is something that you need to even, since you are all working in the same organization, this is something you could look at. Do you have a research agenda in Tanuvas? Is there a way by which you can tell your grant, whoever manages your grant, can we have a research agenda? Can we look at progressively upgrading the quality of research instead of research being relegated to one inventor? Can we say that this inventor does first generation research, next inventor does second generation research or cross-disciplinary research? If you look here, for the first 5 years or 6 years, there is a lot of emphasis on germplasm, screening, selection of varieties and transgenics and so on. No, transgenics is later. So propagation methods and cropping systems. So the first 5 years, they are concentrating on improving the stock and the cropping so that is balanced. The next 4 to 5 years, if you see, there is a lot of emphasis on hybridization, mutagenesis, crop modeling and genomics. And after that, if you see, once they have covered these areas, they move into second generation or third generation biodiesel development. So this is something that you can look at. It is not necessary that only industry people should have an opinion like this. As a corporate strategy, they are looking at innovation. The corporate strategy of that company is innovation. So there is no strategy in most of our companies, like CSIR. What is the strategy, IP strategy of CSIR or ICAR? What is the innovation strategy? What is the invention strategy? There is very little strategy. There is a lot of policy. The policy is always based on two issues, social and budgetary, isn't it? What is the innovation policy and how far does it take them? So here, of course, as a private company, they have also included economic growth, social development and environmental protection. So from their innovation strategy, they attempt to use that. Whereas if we look at our patent act, interestingly, we start from the outside to inward. We first protect those, right? And then we move inwards. I'm not saying it is wrong. It is a different approach. So we can look at a hybrid approach here. Of course, it's a sunrise industry. A sunrise industry is an industry where future technology is likely to be better. So I'm just going to do one more slide and close because I think we're all getting a little tired. The subject of this slide is strategy. How does one get to a monetizable research project? Now, we have to start from there. We can't start in a blue ocean and end up in a destination. It is not possible. It's just not possible. So there has to be an understanding of the translation. We must know where we are going. It can be that we are thinking in a rough way. We are going in this direction. These are the possible destinations. That is fine. But to go without that is very difficult. So the first is asset identification. In the case of Tanuvas, can you just share with me what would be the assets in IP generation that you have?
Our findings.
Sorry?
Our technological findings.
Yeah, your technological findings. So first you would say is your capital, right? Your human capital. Your researchers, your scientists.
Human
Yeah?
resources.
Students.
Yeah.
Resources.
Yeah, so your human capital